Hello, Internet strangers. Welcome back to Hopsy. This is Wireshark 101, where everything we're going to go over is just going to flash on the screen right now. If you've never installed Wireshark, go to the internet, press download, next, install. The default is fine. You're going to land on this interface. You'll see wired, which is Ethernet, and wireless, which is Wi-Fi. We're using Wi-Fi, again, because we're wireless. And the first thing we're jumping into is ICMP. If you don't know what ICMP is, it's just a packet. It's mostly used for DNS resolution to make sure your DNS is working, or to test connectivity, or if some sort of server is up or down. You might want to know either way. So let me filter by ICMP. Now we're going to pull up PowerShell for the test, and we're going to ping Google's DNS server. So I don't actually want to do a DNS resolution. We're just going to ping the numbers 888, 8.8.8.8 is Google's DNS. We see that we've sent 4 packets, received 4 packets, we got 4 replies, and that's exactly what we can see here. So source, this is my IP address my computer IP address. This is the DNS from Google, and then you can see the reply here, also denoted by these arrows. And then we have 4 groups of them, as you can see. Then if we just wanted to, test again, maybe for some reason Google's DNS is down, you go again and you'll see the 4, it's just a repeat of the same 4 groups of packets. Next, we're going to take a look at DNS. So DNS is basically the resolution of a name to an IP address. So imagine here we were typing 8.8.8.8. Instead of doing that, you'll do google.com. Obviously, google.com isn't going to resolve to DNS or resolve to the website. But it's so you don't need to remember literal IP addresses, because if you had to remember an IP address for every single website, people were not going to do that. That's too difficult. So they made DNS. So you just type in a name and it'll resolve. To test that, we're going to go to DNS. I'm going to pull up PowerShell again. Let me just clear, and then we'll bring this over. So we're going to ping google.com. You can see that's being pinged. We should scroll to the bottom because you won't see that in real time. I think this is, well, that's definitely the google.com, but we'll do it again so we get the refreshed. Okay, it's cached it. Let's just do like minecraft.com. Okay, cool. So you can see the minecraft.com DNS resolution, and that's right here. So what's really happening is we're sending 192.168.0 to 175 to the edge of our network. So this is our gateway. And then the gateway, once it gets its response, just sends it back to our computer, so our computer knows where to go. But obviously there's like a magical thing that's happening between like the gateway and the DNS server. So we're going to talk about that. I have a good website to show. And this is the image here. So we're the querying client, obviously, and let's just imagine that this is our whole network. So once it exits the gateway, it goes to the DNS server. The DNS server then sends it to the root server. So here it says the dot. Most commonly, you basically just get sent to the com server, because obviously ours is google.com, minecraft.com. So it knows go to the com server. So root server sends to com server. Com server is like, I know everything in the com server. I know all sub servers, essentially, right? So it knows minecraft.com is a sub server, and that exists here. So then it'll send you to the minecraft.com server, and that will send its resolution, so its IP address, back to the querying client, and then we'll be able to use that address we just got and actually search up where we want to go. And then that's essentially the DNS resolution. So we'll do one more test just to show you, but it's going to do the exact same thing. It's just going to resolve. So ping, why can't I think of anything to ping? Hello.com. Hopefully this is a thing. It is perfect. So hello.com, you got the exact same thing. Goes to gateway, and then you get the response from the gateway. Next, we're going to talk about the TCP Three-Way Handshake. But to do that, we're going to talk about just TCP and UDP in general. Both of them are protocols, but the main difference is TCP is connection-based, UDP is connection-less. So TCP is more reliable. It transfers data slowly because it makes the handshake, and it ensures that data comes in the correct order. If it gets corrupted, lost along the way, it will retransmit the data. UDP is obviously less reliable because all it does is it sends, it's very quick, but it doesn't care if it gets there, it doesn't care if it's corrupted, and it doesn't resend unless you're just going to do like the whole resend. You force request it to resend. But right now we're talking about the TCP handshake. And to do that, you can just go to a website and search. Well, you go to a website and you look at the handshake that's happening. We're going to use this search, which is the middle part of the handshake. So it works SYN, SYN-ACK, ACK. Here, I think I want to use this one because it's going to be a HTTP TCP stream. HTTP is just easier to talk about once it shows up. Yeah, okay, perfect. So we can see this is the handshake here. So this is my IP, this is destination, destination to mine, mine back to destination. And you can literally see the handshake happening. So SYN, this is establishing the connection. This one's saying, hey, we're receiving it and we're okay to continue. And then this is acknowledging that they're okay to continue and the connection has now been opened TCP-wise, right? Now you're going to get like the get, the okay, there might be some posts and stuff. This is just acknowledging the get request. Then you have fin-ACK, ACK, fin-ACK, ACK. That is just how you end. So once the TCP connection is done, you send fin-ACK, and then you get the acknowledgement of the end of that sequence. I believe one of these will be, yes, this is tied to this. So this is just acknowledging this 200 okay. This one is acknowledging this get, as I said before. And then these ACKs, this ACK will be acknowledging this fin-ACK, and then this ACK is acknowledging this fin-ACK. So HTTP inherently is unsecure. And what do I mean by that is there's no encryption. That's why HTTPS exists. And it's very important every website you view and you give any information to uses HTTPS. And we're going to show you that with a great example using VonHub. I just need to open it. There's a login page. We're going to put an admin. I've done this before just to show you a super easy test. Minecraft, not my password. So you know that's what I'm typing in, and you'll see in a second it will come up. Minimize. And now we can look at the network traffic and we see a post. The post is literally going to have the application data in it. So if I scroll to the bottom, you can see user info.php. We can see the forum. We keep going and you get to the encoded application form. And then you see form item, uname equals admin. Form item, password equals Minecraft, not my password. And you're probably thinking, oh, dude, that might not be legit. So let's just do it again. Like, you can show you, so someone else logs in, they don't use admin, they use Hopsy Popsy, and password is still not my password. You type login, you close, and we can look again. This is the new one that was sent a few milliseconds ago. And you scroll down, you see Hopsy Popsy, still not my password. So HTTP, unsecure packets people can just inspect, which is what you don't want, which is why we use HTTPS. And we'll talk about HTTPS in literally 1 second. So that second is now over. HTTPS essentially uses TLS SSL, as I've said. There's different versions. You have TLS 1.3 and 1.2. You can see it here. We're going to look at the GitHub case. So the use case is I'm just going to do the GitHub test where we try and log in GitHub and see the connection. That's logged in. I'm going to use this one because it's essentially the same and I tried it before, so I know what to talk about. You follow TLS stream. Again, TLS is just how it's encrypting the traffic. And inherently, this already looks a lot different to HTTP. With HTTP, you saw the get and post requests. Here, we just see, an ominous application data with really no information provided. So we'll go from the start. We have the TCP handshake obviously being established because it needs to establish before it can do anything else. And then we get the client hello and server hello. With TLS version 1.3, really all that matters is the client hello and the server hello. You'll see that there's a change cipher spec here, but this is actually to accommodate for TLS 1.2, and it's just a dummy change cipher spec. So inherently this doesn't matter for our current what we're looking at because we can see client hello, server hello straight into application data that's encrypted. So it's clearly already working after these two. And yes, this is just to accommodate if you have version 1.2. I think most people are now using 1.3, but don't quote me on that. So inherently, again, if we just look at it from an objective point of view, we know very little. We can see that there's, this TCP, there's a bunch of acknowledgements. I think it's just acknowledging different application data. But like the actual application data, we have no idea. No idea what's inside, and we won't have any idea until the very end. Again, just way more application data, and then we get a reset ACK, which ends the TCP connection. But inherently, yeah, this is much more secure. You're not able to spy on, input passwords. Like there's no point here where you'll be able to see what I put in as the password to GitHub. And this is why we use HTTPS over HTTP to ensure that secure connection when going to websites. So that does conclude the video. If you have any questions, please chuck them in the comments. I'll reply. If you have any other sort of content you want me to do, I'm looking for ideas. I'll try and get back to one video a week. It could be more depending on how difficult the video is to make. But yeah, we all know how the tech market is right now, so you can imagine what I've been doing the last few months. But anyway, I hope you enjoyed. So please comment, like, subscribe, and hopefully I'll see you all in the next one.